Okay, today we're going to go over stacks and queues. This will be the first more of an abstract data type. Beforehand, we've talked about two different concrete data types, namely an array and a linked list. But those are usually used to present other things or other types of data structures that help us solve problems by basically thinking of things in a certain way. All right, learn about stacks. So yeah, stacks and queues. These are both. Wait, did y'all do this in OOP? Last in, first out, first in, first out.
We didn't actually code it, but
yeah. So you talked about it. Great, perfect. So, good. A stack in which elements are added or removed from one end only. Okay, where have we seen this before? Okay, I guess it's Monday, it's early. Where have we seen this before? With our different memories, we've had the static, the stack, and the heap. Luckily in this situation, the stack memory and the stack data structure function very similarly. Point this out because when we get to the heap, which is a data structure, it does not function at all like the memory. Oh. But luckily in this situation, the stack data structure and the stack memory behave effectively the same way. So the idea is you put something on top of the stack and then you remove from the top of the stack. In other words, you're only looking at the top. Last in, first out. So the last item into the stack is the first one to come out when you start removing them. Hey, it's LIFO. All right, we got a stack of coins, a stack of trays, stacks of boxes, a stack of books. Okay. I'm so glad we know about stacks. Hey, look, an empty stack. Oh, we can push A, we can push B, C, and then they use peek, and then they can push D, and then they pop it. All right. With C++, when you pop something, you don't actually get the item. I think if you used it in Java, when you popped, you get the item. In C++, you don't get the item when you pop, it just removes it. If you want to get the item before you remove it, you must first call peek to look at it, and then pop in order to remove it. All right. Okay, great. Let's go ahead and at least start coding this. Ooh, which one should we take? Actually, what data structure do you want to use to solve this? Here, we'll use this picture.
not an array.
You don't. Why not an array? What's wrong with an array?
It's going to copy everything.
You just call mem copy. Anyone else? So if we're not using an array, we're going to use a linked list, because that's basically all we've covered in class. As amazing as that may seem. All right, so 07 linked list. We'll go to 11-stack. Let's just call it LL. All right, let's see what our source looks like. Ooh, we got an HPP. Hey, look at that. It's beautiful. Oh, okay. All right, we're gonna do it manually. But before we do that, let's go and look at a test. Let's see. We don't want to do the SL test. Let's move that SL test to test stack test. And we're just going to include stack.hpp. Delete all of that. Wow, delete a lot of that. That's a lot of deleting. Whew. Okay. So we want to create a stack. And then we want to, well, we're going to push a number. Yeah, let's push a bunch of numbers.
42.
All right. So we push 132, 1, 2, 3, 4, 5, 42. If we do peek, What should it equal?
42.
All right. I don't know why I called it SLL. Oh, I know why, because that's what it was. What should it be here?
5.
Okay. Man, we're doing amazing. Last time.
1, 2, 3, 4.
Okay, great. Amazing. All right, so let's go ahead and try and compile that and get an enormous number of, oh, not too many, just a simple one. Good. So, actually, let's create another window. Again, for those of you that try and look, down here I'm on this one because it has a star. Over here I'm on 0 because it doesn't. I mean, that's another tab I can go back to. All right, source stack dot HTTP. All right, so if we were to look at the test, I guess we should go do that. We want to be able to, well, it looks like we're creating a class here. So let's go ahead and create the class stack. Ooh, that's kind of weird. Looks like my auto indentation isn't working. Perfect. We're going to have some private variables. We want to have some public variables, or actually public functions. And I believe one of them was void push. Wanted to push a value and to peek to return the top value, and then was it void pop? That looks right, right? Yes. Good. Okay. Well then. We have these 3 functions, so let's go over here. All right, we'll just return -1. And yeah, so hopefully we stubbed that out. Let's see if that works. Good. Wow, we typed it all correctly the first time. And by we, I mean I. But anyways. Okay, great. So, how do we make a linked list?
You need a head pointer?
All right, do it. You want to have a node, don't you? I mean,
Yeah. I was like, first, copy over all your signaling stuff over.
or, well, okay, make an instruct. All right. Okay, we can do it this way. Make it a pointer.
I'll do that.
Oh, hey, look. All right. So we're going to make a struct inside private. This is another way to do it, sure. All right, so we declared a struct, a private struct, actually, of our stack class. That does work.
Ouch.
Oh, now we got a head. All right. Let's save that and see if this compiles in case C++ is going to cry or something. Oh, good, it didn't. All right. Oh, by the way, we probably should have a constructor. All right. So what should this constructor do? All right. Let me go ahead and include standard lib. Okay, well, so we have had, how do we push? So did we get little pictures? Let's see. No, they're just talking about the array implementation. Okay. Oh, here we are. So we have empty, and then we push A, and it just contains A. We should do that. We're still got out of insert mode. Ooh. So let's create the node to add first. So node, I like to call it to add. Make it a pointer, of course. Alright, so we have a pointer to a node. Probably should allocate the node. Alright. Anyone help? Alright, well, let's go see what the error is. Hey, it didn't give me an error. That's weird. Oh, we didn't save. Node was not declared in the scope. So, probably should make that capital. Request from inner L value to add, which is a pointer static node pointer. Maybe you meant arrow instead. Alright, go ahead. Make it an arrow. Alright. Now. Oh, that really should have seg-faulted. But it didn't. What do we forget to do?
Declare use.
We gotta make a new node on the heap. There we go. Now we can set the value. What's next gonna be though? Alright. Anything else? Or go ahead. Alright. But if head is null, okay, we'll start there. Great. Okay. So we have a node, points to nowhere, but has the value. Now what do we do? Okay. Alright, that's a good start. What does peak do?
It takes should see the recent value that was entered, that was pushed in.
The value and the node had points to.
Hmm?
The value and the node had points to.
All right, do it.
Is that right?
Yeah, that should work. Let's save that and run it. Let's see, last time we were failing on line 19. Now we made it to 21. Now here. Oh, we gotta implement pop. Alright. How do we pop? But there's no to add. I think you meant head.
Oh.
Okay. All right, let's go see what that does. Ooh, seg fault. Nice. Ooh, we seg faulted on actually we seg faulted on a lot of places. Invalid read of size 4 on line 21. So it's saying on line 21 when we call peak, probably because head is null. But should head be null? Well,
It really shouldn't.
it shouldn't, no. What's happening? Does anyone see it? Y'all see what's going on? Because, yeah, you kept just orphaning these nodes. Alright, so we have head going to next. That's great. So you stack. Hey, it passed. But I bet you this won't. Definitely lost 16 bytes. Indirectly lost 32 bytes. We have a new, but we don't have a delete. Not quite. I mean, you're on the right idea. You want to delete after that line. But what do we need to delete? Yeah, you're right. Delete. What do we want to delete?
The previous head.
I'm sorry?
The previous head.
The previous head. Well, how do we get the previous head? All right. Okay, hold on. Whoever was doing the delete beforehand, Now do it. We don't want to delete the head.
Oh.
It's a kitty purr. All right. So then we delete the previous, and then head is still correct. All right, let's go take a look now. Oh, we definitely lost. Did we not save? Oh wait, I didn't recompile. That explains that. Oh, we lost 16 bytes. Ooh, what did we? What did we not allocate?
I think we popped the last one on the test.
Did we forget? Did we forget to do that? Oh yeah, we didn't pop. All right, let's do the last pop. Nope, there we go. Now the question is, should the final, what should peak do? If you, yeah. What should peak do if you try and call stack.peak here?
Segfault.
Segfault. It should segfault, sure. All right, we'll stick with segfaulting. I like that. Okay, well that was the array. That was a linked list implementation. Was it really that bad? No, it's not that bad. That's great. All right, so we got push A, push B, push C. All right, so I'm going to pause real quick because we're going